Hello and welcome to StarGazers. My name is Katie and I'm here talking to Ashlee Popeman, who is currently studying a degree in environmental science and is knowledgeable in all things environmental and sustainable. How are you going, Ashlee?
I'm going good, thanks, Katie. How are you?
Yeah, I'm pretty good.
Good.
So today you're going to talk to us about something really interesting and probably not really talked about often, which is how rare the colour blue is. And in the simplest terms, can you explain to us why blue doesn't really occur in nature very often?
Cool. Well, I'm no colour expert yet. But a subject I'm currently taking this semester is called remote sensing, which the professor for it summarises as the accumulation of art, science and technology. And as soon as he said that, I was like, this is my type of subject. I like this a lot. So remote sensing is just basically collecting data for things that we can't see with our own eyes. You can think of drones and satellite imagery when you think of remote sensing.
Right.
So to record things we can't actually see, it makes us question everything that we can see and how we as humans process everything we see and how exactly that happens. So unfortunately, I got to start with like really heavy technical stuff, but I'll try and keep it as simple as I can.
Okay.
Which is going to help me because I have an exam for this next week. So I'm really excited to be able to explain this simply. So there's one term called electromagnetic radiation, and I'll just call it EM for short. It's like the fundamental component of our universe. Like all physical bodies emit it, we all emit it, the sun emits it, Earth emits it, animals emit it. And it's created when atomic particles, such as an electron, is accelerated by electric field, causing it to move around. This movement produces oscillating, so spins back and forth of electric and magnetic fields, which travels at right angles to each other in a bundle of energy called a photon, which you may have heard of. And photons travel in harmonic waves at the speed of light. The waves have certain characteristics, that is frequency and wavelength, I should say. A wavelength is the distance between two repeated peaks of a wave measured in meters, and then the frequency is the number of waves that form in a length of time, and that's measured in hertz, which is equal to about one frequency cycle per second. So EM radiation spans a large range of wavelengths and frequencies, and it's known as the electromagnetic spectrum. So this includes things you also probably heard of: radio waves, microwaves, infrared, visible light, ultraviolet, X-rays, and gamma rays.
Right, I'm following.
You following? Brilliant. Stop me if you're lost. So visible light is most important to us humans, obviously. It's right in the middle of the EM spectrum between infrared and ultraviolet. It has frequencies of about 400 terahertz to 800 terahertz. So it has a 400 to 800 terahertz of frequency per second. And a terahertz is 800 hertz followed by 12 zeros. And visible light has wavelengths of about 740 nanometers. So that's 0.000000074 meters to 380 nanometers with 0.0000038 meters. So they're very fast and very tiny. But us humans see visible light as a spectrum as colour. But technically objects don't have colour. Colour doesn't exist. Colour is just the way our brain interprets the EM light wavelengths that pass into our eyes. Our eyes detect this light from little rods and cones in the retina of our eye. The rods detect brightness, so whether something's really dark or something's really light, and then there are 3 different cones that detect blue, green and red wavelengths. All other colours we perceive are just mixtures of the 3 primary colours, and black is just the absence of all light. And the sun is actually white light, because white light is composed of a spectrum of all wavelengths and our visible wavelengths. So white for us contains all colours. The way to see this is what actually Isaac Newton discovered in 1666, where he used a glass prism to project sunlight onto a coloured spectrum onto a wall. And so rainbows are just sunlight projecting through raindrops using this same sort of concept. All objects absorb and reflect EM at certain wavelengths of visible light, and it's called selective absorption. Objects that we perceive as green aren't actually green, they just absorb red and blue light and then reflect the green back to the eyes, back the green light that they didn't want back to our eyes. So this is what plants do. Grass, leaves absorb red and blue colour and then reflect green, so we see them as green. All plants on Earth, even the single-celled plants that grow in the ocean, contain chlorophyll as their main pigment. A pigment is just a coloured chemical that absorbs certain wavelengths of light. From the sun's energy, green wavelengths have the highest radiation intensity compared to red and blue. So why don't plants take advantage and absorb the green wavelength that is most abundant from the sun and has the most energy? Well, it's more of a way for plants to protect themselves. There's too much radiation from the sun is way too much energy that the plants can absorb and actually will burn the plant. So plants have evolved to absorb just the red and blue wavelengths and that don't have as a strong radiation and then reflect the light that may cause them harm. So blue wavelength absorption is used for glue growth, and red wavelength absorption is used as like for flowering and orientating. So that's why plants are green, and we see so much green in the world because plants have evolved that sort of neat little trick.
Right.
But then you see a lot of red in nature, but we don't see as much blue reflect into our eyes in nature. So obviously the sky is blue. So I can start with like why the sky is blue. So blue, it has a shorter wavelength. That is, the wavelengths are closer together and they look really bumpy. And as they emit from the sun, they bump into particles in the Earth's atmosphere. They scatter it around and then they reflect back into our eyes, making the sky appear blue. Whereas red light and green light have like longer wavelengths, which acts more strongly, is not as bumpy and doesn't bump into the particles as much. And that's why sunsets are red, because in the evening the light has more atmosphere to bump around to get to your eye, and only the strong red light can make it. So yeah, there's not much in blue in nature at all. And most of the blue you do see is not actually blue. The blue on most creatures isn't from a pigment like chlorophyll for plants is. The blue most of the time comes from the structure of the blue thing. So when you zoom into a really blue butterfly's wing on their scale, there's these little ridges that are arranged like Christmas trees. So when the light comes in, some bounces off the surface, but some light passes onto a higher branch layer and reflects back to the surface. For most wavelengths of visible light, so red and green, waves reflecting the top and bottom layers will be absorbed. The blue light has just the right wavelength that makes it through the branches to our eyes. So if you grind up the wings and rob it of its reflective prism structures, the wings will just look grey or brown. If you pour alcohol in with them as well, they turn grey or brown. This is the same for blue eyes as well. Most blue we see in nature is not from a pigment, but a certain structure of hair or scales, and every animal or plant has a different way of doing that. A really cool fact is that a 15-million-year-old beetle carcass was found in Germany in like 1998, surrounded by a layer of dull brown and grey fossils. But even after millions of years underground, this particular beetle was still a metallic blue because it wasn't from the pigment chemicals that needed energy to be produced. It was from the structure of the beetle that bent light in such a way that it brought only blue back to our eyes. But there is only one species that has managed to evolve an actual pigment of blue without needing a certain structure. And it's called the olive-winged butterfly. But it's quite rare. We actually don't know much about it, so it's a special little butterfly.
Oh, that's really interesting. So it kind of makes me think, does everyone, because of those pigments, see the same colours, do you think?
I reckon there's probably like no way of knowing if you're the red you see is the same red as I see, because it just depends on how our eyes interpret the different wavelengths. The wavelengths are just how strong the light is. So I reckon we probably do. Our eyes are pretty similar, but then again, we'll never know unless we can like swap consciousness or something like that. But I don't think we'll know.
Right. And so you're essentially saying that the world is black and white.
Yeah, colours don't exist. The only reason we animals have evolved to see colour is to discern certain things and absorb different wavelengths. So flowers and plants, obviously there was maybe, one plant evolved to reflect red light and they were red, but because they then absorbed all the green light, they kind of would not have survived. They would have burnt because the green light has way too strong of a wavelength to actually, or it's too much and it would have burnt the plant. So then, natural selection, the green plants would have survived because these green plants knew how to reflect that light back out. And so they do the same with their flowers. And they didn't probably purposely, like the plant wasn't like, yeah, I'll turn yellow. It was probably just accidentally turned yellow, and then the bees that were pollinating it were like, oh, I can see that colour, that's really cool, I'm going to pollinate that and survive that one.
Interesting. So how does this all connect with the environment and sustainability, do you think?
Yeah, well, remote sensing gives us a way to look at the world differently and more quantitatively so. We can measure areas we've never been to. So the optical cameras on board space telescopes and satellites all have digital cameras, but they take images as grayscale pixels. The images are downloaded as black and white, and then the colour is added for a number of different reasons. Say to show the dispersion of chemical elements, highlight features not on the visible spectrum, so that human eye may see these features and we can study them. So a lot of the photos they take of those beautiful galaxy landscapes aren't actually colourful, they're actually black and white. And if we ever went there on a spaceship to see that, we probably wouldn't see the colours that they actually create these beautiful galaxies to look like. But the reason that they look beautiful is that we take different photos and kind of stitch them back together to identify certain things about that galaxy that we may not have been able to see with our own eyes. And that's kind of what I'm doing in one of my subjects this time. Kind of more simply, not as cool as space travel or anything like that, but we're using remote sensing and our drones flying over certain areas to find weeds of creek catchment areas of Brisbane, to sort of highlight certain weeds and areas that may be overtaking certain like places that we can't actually get to, or it would take a lot of money for a group to actually walk out there. So weeds are actually really prolific in some areas and the main barrier for a healthy creek. And I've had a lot of people ask me, like, aren't there more important things in the world than, weeds growing? Isn't there, like, better sustainability options? Why do we care about, making sure that there aren't a heap of weeds in our creek catchments? And I'm like, sure, that makes sense. But if we let our natural environment fall into disarray, it will ultimately affect our health as a country. Places like China and Mexico have horrible air pollution and environmental pollution. As a consequence, the population now has a heap of health issues. Weeds are a detriment to waterways because they can suffocate the native plants, which are excellent at keeping those waterways together and filtering through things that flow off the roads, whereas a lot of weeds have very shallow roots and they don't hold the creek in together. So when there's a big flood, which does happen a lot in Brisbane, all those plants just get washed away and then there's nothing that can really grow there well again. So weeds are actually great plants. Weeds are just things that are great at growing. They're great at being a top plant in the ecosystem. So that's why there's a lot of native plants that are actually weeds in certain different places because they're just too good at taking over the area. And the most important thing in an environment is the diversity of that environment. Certain plants feed only certain animals. There's a butterfly actually known to Brisbane that hasn't been seen in about 10 years, and it was only known to be in this one area. But there's only one species of plant that it likes. It doesn't like any other species of plant. It only likes this one vine. So I know a lot of people have been trying to plant that around more to try and see if they can somehow get this butterfly back. It's probably hiding somewhere in one small area, and then if we keep building up these vines, maybe it'll come back in the area. But remote sensing also helps us monitor deforestation rates as well, because Queensland actually has the highest rates of deforestation in Australia, and Australia has some of the highest rates in the world, and there's not much regulation, because Queensland is just a huge state in itself.
Yeah.
It's hard to keep track as a human with our small little eyes, and our satellites and remote sensing can help us manage that.
Yeah. Wow. Okay.
That's long info.
That's interesting. I love it. Okay, so I understand that not only that you study environmental science, but also that you write poetry. And you were thinking of sharing some with us.
If you would like, I can share one. I'm trying to get better at reading out my poetry. But it's always, as much as I like to study science, I like having a bit of artistic side in my life, because science is just a way of interpreting the world in an analytical, realistic way, with all our human bias removed. And I see art and poetry is just another way of interpreting the world, but in a very human way, with all our bias and emotions included. So I got a small one I can share.
Yeah, go ahead, do it.
It's called Walking Through the City at Noon. Drunk on a Tuesday, cooked on end of exams day, a warm date set in late June, walking through the city at noon. While there's nothing like a burn on the back of thighs, have you ever sunbaked naked, cooking in skin that's never seen sky? I do miss that beach and that weather, but I would bake all my feelings with burnt sugar, layer emotions with an egg white slather, wish someday for a better someday, I never knew I'd be here on a Tuesday, baking while cooked in June, walking through the city at noon. That's my small one.
Oh, I love it. Thanks so much, Ashlee. I feel like I've learnt so much stuff. So thanks for sitting and talking on our StarGazers podcast.
No worries.
Yeah, it was great.
It's great. Thanks, Katie.